Hi, and welcome to Dr. V's AP Chemistry podcast. In this podcast, I'll be talking about significant figures. This is a way that scientists often will record their data to communicate something about the precision of the measurement, and using significant figures is something AP Chem students are expected to be able to do routinely and automatically when they're recording data and then applying these rules in terms of calculations based on that data. Something you really need to do. For some of you, this may be the first time you've ever encountered significant figures. We'll make sure you have plenty of examples so you feel really comfortable with the rules. For some of you, this is just a quick refresher. Again, we'll make sure you have what you need. Pause the webcast whenever you need to. Write down what you need to. Ask questions if you don't get something. Well, not of me, but of your teacher or a classmate. So what I'd like to accomplish in this webcast is I'd like to go through the rules for significant figures in terms of how many significant figures does this particular measurement have? How do I know that? And then do lots of examples there. And then go through some sample calculations where it's based on measured values. We need to keep track of the significant figures, keep track of that precision, and show you how to do that properly. So let's get right to it. Rule number 1 says all non-zero digits are significant. If it's, numbers 1 through 9, they're significant. Really easy. So the number 12 has 2 digits. None of them are zeros. 2 sig figs. 342, 3 sig figs. 2,223, 4 sig figs. 1,345,678, 7 sig figs. All right, so it's very easy when they're all non-zero digits. We have 4 rules, though, just to deal with the zeros, because we need to be able to handle any situation with the zeros we encounter in terms of how we might report that number. So my next rule deals with what I call captive zeros. And what I mean by a captive zero is that it's a zero in between 2 non-zero digits. Here are some examples. And they are always significant. All right, so if I'm looking at the number 101, this zero is right in between the 2 ones. But because it's in between those, it's a captive zero, significant. So 101 has 3 sig figs. 2008 has 2 zeros in between the 2 and the 8. That's fine. That still works. They're still considered captive zeros and they're still significant. So that has 4 significant figures. All right. The next rule deals with what I call leading zeros. These are placeholder zeros at the left of a number. Usually numbers that are smaller than 1 is when we would write these leading zeros, and they're never significant. Some examples. 0.0012. Well, I've got 3 leading zeros here. They're not significant. Just the 1 and the 2 are significant. So 2 sig figs in that number. I can actually put rules together. So in 0.000103, I have some leading zeros that are not significant and a captive zero that is significant. So this number has 3 sig figs. Sound good? All right, let's go on. The next rule deals with what I often call trailing zeros. These are placeholder zeros at the right-hand side of a number, and they're not significant unless there's a decimal present in the number, anywhere in the number. So let's look at some examples. The number 1,200. There are 2 trailing zeros there, but you'll notice there's no decimal written in the number. This is a detail that is really important. Because there is no decimal, those zeros are not significant. There's only 2 sig figs in that number. But if I record my number as 120.0, still there are 2 trailing zeros, but there is a decimal. And that means that those zeros are significant and there are 4 sig figs. All right, let's look at the next example. I have leading zeros that are not significant. I've got a captive zero that is significant. And I have a trailing zero, but there is a decimal. Therefore, my leading zeros were never significant anyway, and the captive zero was significant, but the trailing zero is significant, which means I have 5 significant figures in this measured value. We're assuming these are all measurements. All right, next rule deals with scientific notation. Now, students tend to like this one because it's very unambiguous. All the digits written in the coefficient, that means the numbers before the times 10 to the whatever part, are considered to be significant. So this is very unambiguous. All right, 6.022 times 10 to the 23rd. I have 4 digits in the coefficient, and therefore I have 4 significant figures. And 4.0 times 10 to the minus fifth. I've only got 2 digits before the x, and therefore I have 2 significant figures. So these are all the rules. Students tend to have the most trouble keeping the leading zeros and trailing zero rules straight. Those are the trickiest ones for some reason. All right. The other thing I wanted to point out is that all measured values are significant. Certainly at some point you learned in class that you look at the smallest divisions and you go one more place. So in this particular measurement, it's marked to the 1 mil. So we're going to report it to 1/10 of a mil. So 43.0 would be an appropriate measurement there. And those are all significant digits because they've all been measured. But they've also been reported properly. All right. The other thing we have to do, and sometimes students find it tricky to keep these rules straight as well, is keeping track of the sig fig rules in calculations. When you do a calculation based on these measured values, you can't get more precise or less precise than the measurements they were based on. You really want to keep that precision. And they're all based on measurements. And you're like, but I don't know what you mean by that, because I haven't really shown you. Let's talk about it in terms of addition and subtraction, those operations, and then we'll talk about it in terms of multiplication and division and show you how we handle it in terms of keeping track of the sig figs. So let's say we want to find the sum of 35.2 meters, 1.724 meters, and 24 meters. So we have these 3 measurements. We want to add them up. They were measured presumably with different devices that had different markings, different divisions. We want to know this total length. All right. So they're all reported to different degrees of precision, to the tenths place, to the thousandths place, to the ones place. We can't be more precise than our least precise measurement. Okay, what does that really mean? If we add them all up on our calculator, we get 60.924 meters. But that's implying that we had more precision really than we did because, for one of the numbers, I only knew it to the tenths place, and for one of the numbers, I only know it to the ones place. So we're going to round our answer based on the measurement with the fewest decimal places, which is the 24, the one we only know to the ones place. What this means is that we have to round our answer to the ones place to report it properly in terms of the significant figures. So the best answer is 61. All right. For some reason, students have a hard time remembering this rule. I'm not really sure why, but I see it over and over again. So try to embed that in your memory, folks. When you're multiplying and dividing, the rule is a little bit different. We still want to pay attention to the precision, but we're going to do it in a slightly different way. If we want to find the area of a triangle, say, that measures 35.6 centimeters by 78.81 centimeters, right, we're going to multiply. All right. We're not going to do it by place here. The rule's a little bit different. On the calculator, all right, you punch your numbers in, you get all these digits. That's implying we have way more precision than we really did. All right, we didn't know it to that kind of depth. We need to round our answer based on the measurement that has the fewest significant figures. 78.81 centimeters has 4 sig figs, and 35.6 centimeters has 3 sig figs. Well, the one with the fewer sig figs will determine the precision that we're allowed in our answer. So I'm really only allowed to report this answer to 3 sig figs, so I need to round, all right, to 2810 or 2,810 centimeters squared. Pay attention to those units. Make sure you've got units on your answers, folks. You never know when you'll need them. Pretty much always. Okay, we'll talk another time.